So hello everyone, in this video we'll learn how the selection sort is implemented and learn about the logic how it is implemented. So we take two pointers, that is I and j. In these two pointers, with the help of these two variables as well, that is minimum value and minimum index. In this minimum value initially we will store 5 and the minimum index as 0, the starting element. Now we'll check with the adjacent element. We see 5 is smaller, so no need to update min value and min index. Check the second 5 and 6. Again 5 is smaller, and we'll check 5 and 2. We find that 2 is smaller, so now we will have to update min value and min index. So we will write min value as 2, min index as 3. And now we will go on checking with 2 and 3. We will find 2 is smaller. 2 and 4, 2 is smaller, so no need to update. So this is the first iteration. In first iteration we found that these two values are min value and min index. We have to swap these two values. So we have a new array in the first iteration, that is the 2 will go here and 5 will go here. So the resultant array is 2 7 6 5 3 4. And now the first element is sorted. Now we'll check from the second element. So this index will be the same, and now min value is assigned as, you can guess, the min value is obviously assigned as 7, as it is starting from 7, and the min index is obviously 1. Now we will see, compare the min value with the adjacent element. Find 6 is smaller, so update the min value as 6 and min index as 2. We will again check with 6 and 5. Find 5 is smaller, so we update the 6 with 5 and min index as 3. And we again check 5 with 3. Find 3 is smaller, therefore we update this 5 as 3 and index as 4. We check 3 and 4. We find 3 is smaller, so no need to update the min value. Now we have to swap these two elements. So in the second iteration, so the resultant array is like this. It will be 3 and 7 goes here. 2 3 6 5 7 4. You have to check this part. These two are sorted. So from now the min value is taken as 6 and min index is taken as 5, right? Now we will go forward. So min value is 6, index as 2. And now we will compare the 6 with 5. 5 is smaller, so we update the values. This one will be 5, this one will be 3. And now we compare the 5 with 7. 5 is smaller, so no need to update. 5 with 4, so 4 is smaller, so we have to update the min value and min index. So now 5 will be 4 and the index will be 5. So we can write the index here. So now the obviously exchange will take place. In third iteration, the resultant array is obviously 2 3 4 5 7 6 is the resulting array. Now you have to check this part, and these three are sorted. In this three part, this element is 4 5 3 4 5, and now the min value is what? Min value is 5 and min index is 3. So we can write it like this, and we check 5 with the 7. We find that 5 is smaller, no need to update. 5 with 6, obviously smaller, no need to update. So this is perfectly placed. So exchange will take place within itself, so the array will be same. Now we go to fourth iteration. In fourth iteration, the array will be same, but we will check from these two elements. This will be I, this will be jth pointer, and I is j is equal to I plus 1 obviously. Now we'll place min value as 7 and min index as what? Min index as ith element, that is 4. Now we'll check these two. We get find 6 is smaller, so update the min value, that is 6, and the min index, that is 4. So now we have to exchange these two elements. So in fifth iteration the resultant array is 2, 3, 4, 5, 6 and 7. No need for sixth iteration, that is already sorted. So I have to run the sort algorithm for n minus 1 array, that is length of the array minus 1 times. So this was about the sort logic. Next video we will see the coding part of this logic. Thank you.